All right. Let's see. Lesson 41, Algebra 1, finding rates of change and slope. Rates of change and slope. A rate of change is a ratio that compares the change in one quantity with the change in another. This feels like a really pretty common thing that I run into in a lot of different math, so don't think that you're ever going to be done with this. This will follow you around life. It'll follow you around from math class to math class, which is things like rates or ratios where we're comparing two things that might be changing. Okay, rate of change. All right, for instance, and my favorite is to talk about going to the gas pump. All right, there is a set rate, which is dollars per gallon, but as the gallons change, so doesn't my total cost change. Okay, so that's a change, but a rate of change could be how things increase in change in rate. Okay. For example, the speed of a car is a rate of change that compares the distance and the time traveled. Okay, increase my speed, decrease my time, right? Okay, so we're going to look at that in relation to slope here in a little bit. All right, the slope of a line. Slope of a line is a rate of change. It's a visual representation of a rate of change. Rise over run, okay, is slope. Okay, and it's always going to be rise over run. It's not going to be run over rise. Okay, so my rise is up and down movement. I can go down, okay, but I'm always reading it from left to right. Okay, so if I have a decreasing slope, I'm going down and over to the right. If I have an increasing rate of change, I'm going up and to the right. Follow me? Okay, a rate of change can be any fraction or a whole number. Okay. For instance, if I am driving 60 miles per hour, right, all that's showing up is 60 mph, but that's actually representing 60 miles over 1 hour. It's still a fraction, and if I was to graph it, I would go up 60 over 1, up 60 over 1, up 60 over 1, right, which would tell me, how long it's, how far I'm going to go. If I drive for 3 hours, I'm going to go 180 miles. Okay, you follow me so far? Okay. All right, so what you see represented over here in our picture is a slope of 4 over 2, which simplifies to 2. I'm going up 2 over 1, okay, or up 4 over 2, okay, or any combination of that. All right. A line with a positive slope rises from left to right, goes up and then over to the right. A line with a negative slope drops, it goes down and then to the right. But there are two other cases to consider, and that's horizontal and vertical lines. Okay? A horizontal line doesn't rise. Okay? And because it doesn't rise, it has a slope of 0, because in terms of rise over run, it's 0 over infinity. Okay, because it's going on and on forever to the left and to the right. Okay, but it has a rise of 0. 0 divided by anything is what? Check it. You pick any number in your calculator, hit 0, divide by, and hit any number in there, and tell me what you get. Okay, everybody try something different. You got a calculator, hit 0, hit divide by, and everybody, in your own head, whatever, make up a number. Could be a decimal, could be an astronomically large number, could be an astronomically small number. But what is 0 divided by whatever number that you came up with? What did you get, Tiffany? Okay, what did you divide 0 by? You divide 0 by? 64. What did you get? 0. Jeremy, what did you divide 0 by? 2, 5, 4, 6, 3, 2, 1. So 0 divided by that, what did you get? 0. Mia, what did you divide 0 by? Okay, 0 divided by 15.673, something like that. What did you get? All right, do I need to go on through the rest of the room? What are we going to get when we divide 0 by anything? 0. So a horizontal line has a slope of 0. Okay, 0 slope. Okay. So the graph of the equation x equals c, where c is a constant, is a vertical line. The slope of a vertical line is undefined. Here's why. Notice if you look at a vertical line, it goes up for, let's say, infinity, right? But that vertical line, is it going to the left or to the right? No. We would say 0, right? What's anything? Pick a, okay, I'm going to come back to the people I haven't talked to yet. Pick any number, plug it in, and hit divide by 0. Okay, I'll give you a second. All right, McEwen, what did you divide, or let's see, what number did you pick to divide by 0? 74,208 divided by 0. What did you get? Infinite? What did it actually say? Okay, it gave you an infinity symbol. Okay, undefined. What did you get? Or what did you divide? 5 divided by 0. What did you get? The infinity symbol. You did it in your computer. Same thing. Okay. Yeah, in your graphing calculator, you'll get an error. Abby, did you get the infinity symbol? Okay. Got an error. Okay. Because it's undefined. Okay. Anything divided by 0 is going to be an error, or in some calculators, undefined. Okay, we can't in those of you that got infinity, can you define infinity? No. In fact, really probably what your computer should have showed you is if it was going to show you infinity, should have been positive or negative infinity, right? Because it's dropping at the same point as it's going up, correct? All right, so infinity is an undefined term. So a vertical line has a slope that is undefined. Okay, next lesson, 42, solving percent problems. This stuff should be review, I think, maybe? I don't know. I don't know what you know and what you don't know. Okay, a percent, right? Are we familiar with percents? Okay, great. We're familiar with decimals. Okay, great. So a percent, yeah, Tiffany? I'm sure that there is. Oh yeah, I put Algebra 2 up there, didn't I? Yep. I'll fix that for you. All right, Algebra 1. All right, a percent is a ratio that compares a number to 100. It's a number that we'd put over 100. For example, 50% is the ratio 50 over 100, which is, we could reduce that to get a fraction of 1 over 2, correct? There are 3 components that form a percent statement. You have the whole, which is the total amount. The percent is a rate that quantifies an amount measured with respect to the whole. And then you have the percentage, is a number that represents a percent of a whole. So percent, we would get 25%. Or we could say, 25% of 20 is 4. Okay, so we have our whole, which is 20, and the percentage is 4. So if 2 of the components are known, then any one of the components can be determined. All right, a percent statement can be set up as a proportion. A lot of you, I think, probably already solved these this way. One ratio compares that the part of the quantity of the whole quantity. The other ratio is the percent rate written in the form of a ratio. So part over whole equals percent rate. Okay, for example, 10% of 50 is 5. Okay, and you see that worked out down here. 10%, that percent's going to be written over 100. Of 50. 50 is my whole. I'm comparing it to the 100. So the part that I'm looking for would be 5. Okay? If I want to know what is 10% of 50, I can set it up as a proportion. Does that make sense? I go too fast for anybody. It's just confusing. Some of you have got it, some of you maybe not. Okay? All right, so let's do this. Okay? Let's cover some questions in here, and then we will shoot into your book and try to cover at least a couple of practice set questions from each lesson. So what is the slope in the line graph? Well, where do I want to start from? Where would you start from, Caden? I'll give you, maybe this is new enough to you that a lot of you maybe aren't sure. Always start from the y-intercept. Is that what you're going to say, Jeremy? Start from the y-intercept. And then I want to go until I find what? I'm going to look down that line until I find where it crosses at a nice, neat coordinate. Okay, if I can. Now, more complex questions, your y-intercept won't be nice and neat, and it may be a while before you find. All right, so what do I want to do from the blue dot to the red dot? And do I want to count to the right, or do I want to count up or down? Yeah? Count down, okay? So in this case, I'm counting down. I'm counting down 1, 2, 3, right? Okay? So in terms of my slope, right, what number goes on top? -3. And then I'm going to go over 2. Okay? -3/2. Does that make sense? Okay, if it doesn't make sense, it won't do us any good. All right, hopefully that works for us. All right, 170% of 54 equals what? All right, so let's try to set up a proportion. Okay? What should go on the bottom right? 100%. And I'm not saying that you can't write it any differently than this, but I'm just going to try to stay consistent. What goes above 100? 170. Okay? All right, where's the 54 go? Bottom left, right? Because that's my whole, correct? All right, so I'm trying to solve here. Now, this is where it matches up really well with what we learned yesterday in that, what am I going to do here? How do I solve for that x? All right, so the step is cross multiply, right? 170 times 54. Probably need a calculator for that, right? I don't know. You guys don't remember your 54 times tables? Okay, I don't know why you guys aren't working on your 170 times tables. Okay, what's 54 times 170? What's that? 9,180. What does that equal on the other side? I mean, cross multiply, let's 100x, right? I want to solve for x, so I'm going to do what, Jordan? Divide by 100, he says. On both sides. Abby? You got an answer? Okay. What did you get for x, Abby? 91.8. Okay? 91.8. Right there. Okay? Good with that so far? Okay. So that's one question, and there's certainly more questions in here before I get too far into just working out a bunch of these. And there are several that we could look at, and several that you ought to look at, okay, because several of these might show up on a test at some point. Okay, I want to look at some homework questions. Okay, so lesson 41, I want you to look in there. You got A through F there. Pick a question out between A and, actually it goes all the way to H, doesn't it? Yeah. A through H. Try to find something in there. Now a lot of these are visual, so it's going to be a little harder to put on the board. Or you can go ahead and find something from A through F from lesson 42, whichever you think you're going to need. B on 41. Okay, B. All right, B on 41 says use the table to find the rate of change. Okay, so in my table, okay, we've got miles. Okay, and we have feet. Okay, we got 3, 5, 7, 9. Got some big numbers here like 15, 840, 26, 400, 36, 960, and 47, 520. Okay. Now, the answer to this question is fairly obvious if you know what the question is getting at, right? The rate of change is feet per mile, okay? So if I do this as feet per mile, that's 15,840 over 3. You know, that's 26,400 over 5. That's 36,960 divided by 7. Okay, well, what's 15,840 divided by 3? $5,280. What's 26,400 divided by 5? 5,280. What's 36,960 divided by 7? Okay, and could I go ahead and assume that 47,520 divided by 9 is probably 5,280? So what is my rate of change? All right, specifically feet per mile. Okay. All right, you got time? Let's see if you can find something from lesson 42 that you might need to help you out. You got an A through F there. F, people always pick the word problems. Don't want to do word problems. Okay. But the only way for you guys to get better at it is to work these through. All right. So a school raised $15,432 for a new computer. The money will be allotted as follows. 50% is going to be for construction costs, 45% for technology purchases, 5% for incidental expenses. Using a proportion, find the amount that will be spent on technology purchases. So do I need all of everything that's been given there? What is the percent for technology purchases? What percent? 45%. All right. So 45% of what? $15,432. Okay. So if I'm going to set this up, okay, just try to be consistent here. Okay. What number goes bottom right? 100. Okay. What number is going to go on top? 45. Okay. What number is going to be bottom left? Okay. And X could go right there, right? Okay, or T or whatever you want to call it. So this part of the question, this is part of your answer, is this right here. Okay? The other part of your answer is X equals in dollars. Do you guys think that you can solve that? Was it easier than what you thought it was? Okay. All right. At this point, I'm going to end right here with the video and let you guys work, okay?